Hello everyone and welcome to my channel. In today's video, we are going to talk about something about this post-Xenon lamp trigger circuit. I believe some of you have seen my videos about the Xenon flash previously. And as you can see, the main discharge, the energy is delivered from these two electrolytic capacitors, which will be charged up to 300 volts roughly each. And to charge the capacitors, I use a 4-bridge rectifier in series with around 200 watts incandescent lights. They are in series with the main power supply, and the bridge output, the plus and minus output from the bridge, are connected to each of the capacitors in turn. Now the power has been cut, so it's very safe to touch these things. And as you can see, this is a triggered transformer in series with a lamp, and with this inductor in series with the main capacitors. So this one here is used for trigger, high voltage trigger, this lamp. As you can see, I just use a simple step-up circuit and a microwave oven diode to rectify around 500 Hz high voltage DC output from this inverter, and to charge these three capacitors around 2 kilovolts and 0.2 microfarads in total. And I made a very simple spark gap. You can see this is a spark gap, tiny spark gap, right? This spark gap is in series with the primary of the post transformer, then in parallel with the capacitors. So if this spark gap is triggered, then the high voltage will be applied to the primary of the transformer, and the high voltage will be produced between the secondary windings. And let's test it. Maybe it's hard to see the flash inside the tube, but I believe you can see some flashlights coming out, right? This is a function of the post transformer, and because since this is a high dV dt pulse, the electrolytic capacitor has very low impedance to this pulse, but this inductor here has a very high impedance towards the pulse. So these two capacitors are in series and then in parallel with the inductor to bypass this inductor to the high voltage pulse, trigger pulse. So the trigger pulse just comes through the capacitors, through these two capacitors, and be applied to the lamp. Okay. So let's talk about the function of this ultra-fast recovery diode. This is a 40 amp and 1 kilovolts rated diode made by international rectifier, and you can see it's anti-parallel with the main capacitors, which means it will be it will block the current through it when the capacitor is charging. But when you discharge the whole circuit, because of the inductor here and the leakage inductance of the triggered transformer, there needs to be a freewheeling diode in parallel with the main capacitors. Otherwise, the current will charge the capacitors I don't know how to explain that, sorry, but I believe you can understand me. Okay, so what's the function of this inductor? This is a very important component in the whole circuit, and this is why I can safely operate this small lamp under a huge, very large stored energy. This inductor is to limit the current increasing rate through the whole discharge circuit. Here, this inductor in series with the leakage inductance of the transformer is around 200 microhenry in total. So the current will be limited through the lamp, and this is a very important component in your circuit. If you do not have the inductors, this lamp can only be operated under around 300 to 400 joules stored energy. But with the series inductors, I have safely triggered this lamp for around 20 to 30 times under 5.5 kilojoules each time. But what you need to keep in mind is that if you enlarge the stored energy, the total energy released will not be reduced by the inductors. They just limit the current rising rate. That means they will limit the pressure rising rate in the lamp, but the total energy released will not be limited or reduced. So the lamp will get very hot, extremely hot, if you use a larger stored energy than the manufacturer recommended. So with a larger energy stored, the lamp may not be able to cooled by water, because if you immerse the whole lamp in the water, the huge temperature difference through the 1 millimeter glass, the quartz glass, will cause a huge force through the glass, and it will leave some cracks along the lamp. The lamp will not be exploded at the first pulse, but it will explode when you triggered it at the second time, if you immerse the whole lamp inside in the water. So with a large stored energy, you need to cool the lamp just by air, and you need to keep in mind that after each pulse you need to wait for the lamp to cool down to room temperature, to ambient temperature, fully cooled down, and then you can trigger it for the second time. And you must wear safety glasses or other protective wearings during the test. It's very dangerous to operate the lamp over the recommended explosion energy. And that is all about this circuit, and after a few days I will come home and I can test some huge laser cavities, because I have ordered a professional laser power supply, and it's 12 kilowatt power supply. So hope you enjoy my video, and hope you have learned something in today's video.